In previous videos, I described how C allows you to define blocks of memory and refer to them by name. These memory blocks may contain values only. These are called variables. However, other types of memory blocks may contain instructions for doing stuff, as well as values. These are called functions. So far, I've only talked about variables. Today, I'll introduce you to functions and some of the remaining elements we need in order to construct a working C program. Functions are blocks of memory that do stuff. So, before diving into explaining functions, I'll first explain the basics of how to do stuff in C. A basic instruction in C is called a statement, and is composed of some source code that tells the computer to do something followed by a semicolon. We say the semicolon terminates the statement. Statements may include a variety of sub-instructions. These are declarations, which we've come across previously in regards to variables, and expressions. An expression tells the computer to evaluate some calculation or comparison, so by the time the computer finishes processing an expression, it ends up with a value that it stores in some memory location. Each statement may include no expressions or several. In previous videos, I showed many examples of statements and expressions without telling you that that's what they were called. Here's an example of a statement without an expression. This is a declaration statement. In obeying it, the computer will reserve a block of memory that can hold a value with a data type of signed int, and will associate the address of that particular block of memory with the name mySI. At this stage, the value of mySI is undefined. It may be 0, or it may be any negative or positive number that can be represented by a signed int. What value it has will depend simply on what bit pattern just happened to reside in the memory location the computer allocated to this variable. In most cases, this value is not helpful because you would want to control what value your variable starts out with. One way to do this is with an assignment expression that comprises another statement, like this. But we could have made this assignment expression part of a larger statement if we combined the declaration statement with the assignment expression, like this. Note also the use of a comment in this line. A comment is some free text that you include in your program purely for annotation purposes. Comments are ignored by the compiler. In the original C89 standard, comments had to be enclosed between / brackets like this. Such comments could span multiple lines until whenever the closing / bracket appears. However, since C99, a single line comment can be made with just a double /, and all text after that will be ignored by the compiler till the end of the line. Now back to our statement examples. You can also have multiple expressions in one statement. Consider this example. This statement is made of two expressions. 3 plus 5 is the first one. The computer will compute the expression 3 plus 5 and keep the result in some temporary memory storage area. Then the second expression, mySI equals something, will be evaluated, with the something being the result of the first expression. Another class of expressions are the comparison expressions. In C, we have the set of comparison operators shown in the table. These can be used in many circumstances. Perhaps one that will be familiar with anyone with even the most cursory knowledge of programming or algorithms in general is the if, then, else control of flow operators. In C, we don't use the word then, that's just taken to be implied, but we do have if and else. For example, this statement will increment mySI by 8 only if the value of mySI is initially equal to 10. In this statement, the expression in brackets is evaluated. If the result is non-zero, then the if condition is satisfied and the rest of the statement will be performed. Otherwise, it will not. In general, when evaluating conditions, the condition is considered satisfied or true if the result of its evaluation is not 0. It's false otherwise. So, you don't need to have any special logical or comparison operators in the brackets. You could just have a constant value, like this. This will only do the rest of the statement if the initial value of mySI is not 0. Conversely, we can switch this around with the not operator like this. In this example, if mySI is not 0, then pling mySI will be 0 and vice versa. So the rest of the statement will only be done if mySI itself is 0. Compound comparisons can be made by linking multiple comparison expressions with the logical OR and AND operators, as in this example. Here, both expressions must be true to continue because they are combined with a logical AND operator, so my SI must not be 0, and my SI must also be less than or equal to 3 in order for the rest of the statement to be performed. In C, you can group multiple statements into a code block using braces to form a compound statement like this. In the previous section, I showed how the if keyword can be used to control execution of a single statement. Using code blocks, you can extend that control to cover a compound statement like this. But you don't need any conditional filter to have nested code blocks. For example, you can do this. In this example, we create a block within a block and use it to declare a new signed int variable called mySI2. We then do an assignment expression statement which copies the value of mySI into mySI2. So after this line, the value of mySI2 will be 8. One important feature of code blocks is that variables declared inside a block are only accessible to code inside that same block. For example, if we add a line after the nested block in our example like this, the computer will give us an error and won't compile it because the variable mySI2 was declared inside the previous block. After that block closed, the variable mySI2 is no longer visible to any code outside the block. We say the scope of the variable mySI2 is local to the block it was declared in. This is why the variable mySI can be used inside the nested block, because the nested block is still within the block that mySI was declared in. You can also declare variables at the top of your source code file outside any blocks, like this. In this case, myUCGlobalVar is available to all the code that comes after it. We say it has global scope, and so is called a global variable. We now have enough background knowledge to discuss functions. I'll begin with a general overview. I'll get into specifics later. A function is a block of code containing one or more statements which perform some task. This code block is associated with some custom name label. The task which the function performs can be run by simply writing the function's name in a statement from anywhere in your program where the function has scope. The act of writing a function's name in order to run it is called calling the function. When the function completes the task described by its code, control of the program returns to just after the point in your program at which the function was called. Functions are essential to C. In fact, you can't have a working C program without at least one function, a special function which defines the starting point of execution for any C program. While the naming of custom functions is up to you, this special entry point function must be given the name main, and every C program must have one and only one main function. Functions can receive input data from the caller as values held in variables that are local to the function. These input values are called arguments. The arguments of a function are represented in plain brackets after its name. Functions can also produce some value as a result of their task. This is called the return value of the function, and the return value must have a data type just like any value associated with a variable. Some functions take no arguments. The argument list in their brackets is said to be void. Some functions do not return a value. In that case, the function's data type is also described as void. It is possible to have a C program where all the processing is done entirely in the main function. But this is uncommon because even very basic tasks like simple input and output will usually be done using other functions. Whenever you need to perform some task over and over, possibly with different input data each time, it's more efficient in terms of avoiding repetition of code to parcel off that task as a custom function, then simply call the function any time you want to do that task. You can call a function from within any other function. You're not restricted to calling functions only from within main. You can even call a function from within itself. This is called recursion. So, that was an overview of functions. Now let's get down to the specifics. I noted before that a function is just a block of memory you can access with a name, like a variable. But an important difference is that functions do stuff. Because functions may return a value, they are also associated with a data type, just like variables. The return value of a function is equivalent to the stored value of a variable. So, just like variables, functions need to be declared before they can be used, and you do this in a very similar way to declaring variables, by starting with the data type of the function, or void if it returns no value, followed by its name. But with a function, you also need to declare the data types of any arguments it takes, or use void if it takes no arguments. You must terminate the declaration statement with the usual semicolon. There's no need to give names to the argument variables in the declaration, although this is allowed, and some programmers do this to help make the code more readable. Argument names given in a declaration are effectively comments. They are ignored by the compiler. The details of a function's data type, name, and argument data types provided in a declaration statement is called the function's prototype. With a variable, declaration is all you need do before using it. But you can't use a function until you have also written the code which dictates what stuff it does. This is called defining the function. Defining a function begins with something that looks very similar to the declaration of that function, with two caveats. The first is that you must put the names of any arguments in the argument list if it is not void. These names will be the names of variables you will be able to use in your source code inside the function. The second caveat is that instead of just a semicolon, you must specify the program statements that go into defining what your function does. This may be a simple one-line statement like this, or multiple statements in a code block. Defining a function on its own is sufficient to create a function. You don't need a separate function declaration statement. However, a function only has scope after it is either defined or declared. So, if you have lots of functions that need to be called from within each other, it can be useful or even essential to put all the function prototypes, that is their declaration statements, at the top of your program so that they can all be seen by each other without you having to worry about the order in which they are eventually defined. This separability of function definition and declaration is also useful when it comes to making function libraries and header files, discussed next. If you have a collection of functions you use often, you can define them in a separate source code file that does not have a main function. This can be compiled into machine code, but the machine code file resulting from this cannot be run on its own because there is no entry point to begin execution. However, the code in this file that represents any of these functions can be linked to your program that you write and compile separately. Such separate files that contain only non-main functions are called libraries. In order to use the functions defined in a library in your program, you'll need to include the prototypes of those functions somewhere in your source code, usually at the top of the source code, to ensure these functions have global scope in your program. Rather than you having to know and type up the prototypes of all these library functions at the top of your source code, most libraries come with a file called a header file, which has all the function prototype declarations correctly typed up for you. Header files may also contain the declaration of specific variables that are used in conjunction with the functions in the library. These header files have a .h extension. C allows you to include any such header file into your source code with a #include directive. So, for example, if I wanted to include functions provided by the standard input-output library that comes with most C compilers, I could write #include stdio.h at the top of my program, and this will give me access to useful functions like printf that lets me print information to a standard output device like a terminal window on my monitor. Note that this #directive is not terminated by a semicolon. This is because strictly this is not a statement to be compiled into machine code, but a directive to include some other file into your source code prior to compilation. The whole compilation process encompasses such pre-processing as a prior step to actual compilation. The part of the compiler system that does this kind of pre-processing is called the preprocessor, and all instructions or directives to the preprocessor are made using commands that begin with the # symbol to differentiate them from statements that need to be compiled into machine code. After your source code is compiled, the actual machine code of the functions from any libraries you've included will be linked to your compiled program using a post-processing program called a linker. So, the process of turning your source code into a complete executable machine code program actually involves 3 main steps: pre-processing, compiling, and linking. I'll say more about the practicalities of compiling a program in the next video. We've seen what functions are, how they are declared and defined, and how they can be parcelled off into separate source files for convenience. But how do you actually use or call a function from some point in your code? Well, you simply state the name of the function together with any arguments in your code as shown in this example. You access the return value of the function by using the function as if it were a variable having a value, like this. In this example, rval, which started off with some undefined value because we didn't initialize it, will end up taking on the return value of the squaring function that was called with the argument ival. Because the value of ival is 3, this means the return value of the function will be 9, so rval will take the value 9. Note that the arguments to functions are always passed to the function by value. This means that a copy of the value of the variable used as an argument is passed to the function, not the variable itself. In this example, the value of ival is 3, and so this value 3 is copied into the variable cval that the function defines as its argument. The value of cval is changed in the function, but the value of ival itself is not altered. If you want a function to actually alter some variable that is not local to the function, then you must pass the address of the value you want changed, as in this example. In this example, the function makes a copy of the address of your local variable ival and stores this address in a pointer variable, which is its argument. It then accesses and changes the indirect value of that pointer to change the value of your original variable ival. Because this function does not need to return a value, it has a data type of void. Note that its argument is of data type pointer to int. In summary, statements are one or more declarations or expressions terminated with a semicolon, and compound statements can be made by grouping statements in between braces. Declarations of variables and functions must come before they are first used in order to be in scope. Scope is limited to within the code block an item is declared in, or can be global if the declaration is made outside and before all code blocks. All C programs must have at least one function called main. Other functions can be defined in the same source file or in separate source files, in which case they can be linked to your program at compile time by including a header file containing their prototypes in your source file. Function arguments are always passed by value. Use addresses and pointers if you want to change the value of a variable that is not internal to a function. If you like this video, please hit the thumbs up like button and view some of the other videos on my channel. If you'd like to support the project, you can do that by subscribing to this channel and telling others about it. If you'd like to help me continue this work, take a look at my Patreon page, where you'll find additional content and early bird access to future videos. Thanks for watching.